So, what is the problem? Well, the waste that doesn't re enter the economy, the non recoverable waste, has to be disposed of in some way. This waste is transported and deposited in sanitary landfills, which are final disposition sites that have different layers of a certain thickness where waste is stored. The issue is that sanitary landfills have limited capacities and therefore limited lifespans. And waste production is constantly growing. In fact, in 2018, the World Bank announced that our global waste production is predicted to rise by 70% by 2050. Locally, the Superintendents of Public Utilities indicated that 32,580 tons of waste were disposed in sanitary landfills in 2020, with the National Report on Solid Waste Disposal acknowledging that 23.3% of the landfills have less than 3 years of operations left before they exceed their capacity, and thus, experts have referred to them as possible ticking time bombs. We have talked about the sanitary landfill's lifespan, but what do we mean by recovery rate? It is simple. We know that there is recoverable waste and non-recoverable waste. The recovery rate simply states the relationship between the total disposed waste and the recovered waste. It is defined as the total waste recovered in tons over the total waste production in tons. This is important as an increase in the recovery rate means that less waste is being disposed of in sanitary landfills. Thus, this will become an important variable of our analysis, as it is a public policy objective to increase the recovery rate. Now, we will address how we tackle this problem using data science. First, the data. Our primary source of information were monthly and public datasets on disposed tons, otherwise known as non-recoverable waste, effectively used tons or recoverable waste, multiple variables pertaining to sanitary landfills, including its lifespan, and data on population by municipality. Secondly, we conducted a descriptive analysis of our data, choosing the best visualizations that help us understand it and complementing it with a geographical analysis. Thirdly, we used the k-means clusterization methods to find out the placement of the country's sanitary landfills according to their recovery rate and lifespan. Finally, we gathered all of our approaches and built them into an online dashboard easily accessible to any user.
Created using Powtoon.